We are looking at this problem binary search. Given an array of integer nums, this one, it is sorted in ascending order. As you can see, we need to search for a target and we have to write a function for it. This is the target given. We need to look for this target in that nums array and return its index. If it is not present, return -1. This is a classic binary search problem. It's return binary search. It has a time complexity of O log n. If you're not aware what binary search is, let me give you a quick look. Let's say we have these numbers. I want to look for 9. What would be a very simple approach? Let's go through every element. So let's keep a pointer over here. Let's look at -1. Is it 9? No. Let's go I plus 1, which is here. 0. Is it equal to the target? No. And continue going forward. So you have 9 over here and you return its index. What would be the time complexity? O of n. Now this time complexity is not acceptable. We need to do it in O log n. So how can we do? We would use the ascending nature of the problem, the ascending order. At any point in time, let's say at this location, can I reject an entire part of the array and say this part cannot have the target at all? Like this part, can it ever have 9? No, because 9 is bigger than 3. So you basically reject this part of the array. This part of the array, there will be 9 because 3 is smaller than 9. So there should be 9 after this. This question gives us ascending order, but even in a descending order, we can predict on which side of the array the target would be. So let's now run this algorithm. I have these numbers. The low is at 0. The high is at 5. What would be the middle point? Let's do it using middle point. There are many different points that can be taken. In this question, we are supposed to take the middle point. So what would be the middle point? That would be the index of low plus high divided by 2, 0 plus 5 divided by 2. And it's a integer division, so it would be 2. What is index 2? 0, 1, 2. We are over here. Is 3 the target? No. On which side the target would be? On the right side. So we would reject this entire part, which means we would say L is equals to m plus 1. Why m plus 1? Because this element is already considered. There is no need to look at it again. So we are over here, L is over here, H is over here. Let me clean this up. Now, what would be the middle point? 5 plus 3 by 2, that is 4. So we are over here. Is this the target? And the answer is yes. We got the target. Now look at another scenario. Let's look at this. The low is over here, the high is over here, low is 0, and high is 5. Middle is low plus high by 2. That would be 2 again. We are over here, we need to look for 2. Is 3 equals to 2? No, so we have not found anything. But on which side of the array 2 should be? On the left side, right? It's less than 3. So this time we would move high. High would be moved to middle minus 1. This is the midpoint. This is the high point. Now we have high at 1, low at 0. We need to find the middle. So the middle would be 0 plus 1 divided by 2, and that would be 0. So we have a middle at this point, which is minus 1. Is this equal to 2? No, it's not equal to 2. 2 should be after, right? 2 should be after minus 1. On this side of the array, we have minus 1, 0 at this point in time. This is low. This is high. 2 should be on the right side from the middle point. Okay, so what would move? The low would move. Low would become middle plus 1. So low is at high. So now we have just one element. It's low and it's also high. What would be the middle? The element itself. Let's check if this element is matching with 2. It's not. So what happens next? On which side can we find an answer? Now we know we cannot because we know it's just one element. But on which side we would find the element? On the right side, right? The 2 should be somewhere here. So what would move? The left side. L equals to middle plus 1, which would be L is what? 1 and H is 0. They switched. The high side is after the low side, and that's not right. So we know that we do not have a solution and we return minus 1. Now let's take a look at the code. First of all, we need a low. Low would be 0. High would be length of nums minus 1. It's the last index. We can say while low is less than high. Remember the last condition? While low is less than or equal to high, we want to still check even if they are equal. Let's calculate the middle point first. So middle point would be low plus high, integer division by 2. If the target matches with the number at this place, nums at middle, we found the answer. We can return this m, which is the index of target. Otherwise, if target is greater than nums, if target is greater, which means we are at a smaller position, so the in a ascending uh, array, our solution is on the right side. So low moves to the right, m plus 1. Otherwise, we are just left with one condition where the target is smaller than the nums of m and the right moves to m minus 1. That's it. If we do not return from this place anytime, which means we did not find anything, the while loop completely exhausted, so we can return over here minus 1. Let's try to run it. So I made a mistake assigning this variable to r. It is h. We have a successful execution. Let's submit it. We have it passing.